Hello and welcome to Chapter 2 of the OpenStax Psychology textbook. Today we're going to be going over psychological research. My name is Matthew Poole and I'm an instructor of psychology at Northeast State Community College. Let's begin. So, why is research in general important? Back in the day when we didn't have the scientific method, a lot of what we did was relying on intuition. So, these are our own personal biases and opinions on how we should navigate reality. And as you could probably guess, this obviously didn't lead to the best outcomes. So, this is why we need science in place and research in place, utilizing empiricism so we can come to objective or unbiased conclusions about our world. So, we can follow through with them, we can repeat them, and come to the same conclusions. So, this is why psychology is included within this chapter as well, is because back in the day, what they did and the predominating thought around why people experienced the mental difficulties that they did was because of demonic possession, witchcraft, things of that nature, just supernatural experiences, supernatural causes. So what they did was they would engage in an activity known as trephining. And so what trephining is, it's effectively just drilling a hole in your head to try and let the demons out. Now, as you would expect, this killed a lot of people, and this was not productive as far as alleviating mental difficulties. So, this is now, thankfully, with the scientific method, we have improved tremendously since then. Of course, there's still room for growth, as any scientist will, make that claim. If there's a scientist that says they're 100% accurate, then you want to be wary of them because they always leave room for improvement or to be proven incorrect. So, that being said, is of course included within this. Some people will argue that it's a hard science versus a soft science. You're welcome to have that debate. But by definition, we do apply the scientific method to behavior and mental processes that are observable so we can reach repeatable conclusions that, again, are unbiased and are able to be proven. The hypotheses are able to be proven falsified. Okay. And that's the biggest key mark factor here is you can't even get started with research until your hypothesis is able to be proven incorrect or it is falsifiable. Now, next, as you all know, programs and institutions, businesses in general constantly will claim that either their product or their methods are based on scientific evidence. Now, one of the organizations that was caught in the act was DARE. I'm somebody that went through DARE growing up, and I don't think that their methods were too particularly effective on some of my peers and their use of substances after going through this program. However, the biggest key mark issue with their, according to your textbook, is that they claim that their methods were based on scientific research and scientific evidence. That was not the case. So again, anytime it comes to science, anytime it comes to coming to conclusions on what you believe in, it's always good to get multiple opinions. Don't just rely on one piece of evidence to support your claims. That's called an anchoring bias, which is something that we'll talk about in later chapters. So always do your due diligence, always fact check, get multiple opinions, and do your research to make sure that your claims are as unbiased as you can make them. Okay. Now, when it comes to deductive versus inductive reasoning, I like to call science like a tornado of improvement. It's constantly building upon itself over time. So, when it comes to deductive reasoning, this is whenever we have broad generalizations or hypotheses and we turn them into specific conclusions about the real world. And so with science, it doesn't just stop there. We're not just satisfied at having this one piece of evidence. We want to take those findings and branch out even more so we can make more hypotheses to then make more conclusions. So that's why I call it a tornado of improvement over time. It's cyclical. Okay. Inductive reasoning, again, is whenever we take those specific conclusions to construct broad generalizations. All right. And then the process just continues to repeat over time. So, deductive reasoning going from general to specific, inductive going from specific to general. Something that you're going to be tested on if you're in my class. If you're just watching it for fun, don't worry about it. Now, when it comes to the scientific method, people will think of the word theory and think that it doesn't have any real support to it. And I want to eliminate that understanding right now. Theory in science is one of the highest honors that you can get. It explains how an observed phenomena has occurred. It has a well developed set of ideas that support it. It does have research to support it, explaining why something happened, maybe why it's the Big Bang Theory. Now, when it comes to the process of the scientific method, I like to remember it like this. It starts with a question. We always have to question something. Okay. Then we have to have a hypothesis. Okay. And this hypothesis, to give a definition to it, is just a testable prediction about the relationship between two or more variables. So it predicts how the world will behave if the theory is correct. It's usually an if then statement. So if this happens, then this will occur. And most importantly, it is falsifiable. As I've mentioned, probably ad nauseum up until this point, it has to be shown that it is incorrect. So a hypothesis is a testable prediction. Okay. Next, we have to test this hypothesis through unbiased measures. We have to eliminate bias as best we can. And we'll talk about some ways that we can eliminate bias throughout this chapter. Next is we have to analyze the data that we've come to. All right. So once we analyze, then we can come to adequate conclusions. All right. And so when we come to conclusions about our hypotheses or our original question at hand, it doesn't just stop there. We don't want to just keep our findings to ourselves, right? We need to report that information to an academic journal or article so it can be peer reviewed and signed off and said, yep, this is adequate. It is good to go. It is considered scientific. Okay. And as I mentioned, the in chapter one, Sigmund Freud threw out a good bit of theories, some better than others. I will be honest with you, but I say he's like the king of unfalsifiability. It's because he threw out a lot of hypotheses that you couldn't observe. So, for example, Freud thought when it comes to personality, you have what's known as an id, ego, and superego. And if there's a conflict between them, then it could lead to psychological distress. And just to briefly explain it, your ego is like you in the center. If you've seen these in movies and TV shows, then you know exactly what I'm talking about. You yourself are the ego dealing with a difficulty. And then on your left and right shoulder, you've got a devil and an angel. In this case, the id is like the devil on your shoulder. It relies on the pleasure principle. It wants what it wants, when it wants, and it doesn't care who it has to step over to get what it wants. Then it's got the super ego, which is like the angel on your shoulder. All right. It relies on doing what's right, the perfection principle, doing what's right every time, no matter what. And then ultimately, the ego is you in the center, having to distinguish and decide between the two, trying to satisfy the id, but in a socially acceptable manner. The ego relies on the reality principle. But although that sounds all good and maybe even plausible, sometimes I feel like I've got a devil and angel on my shoulder. We can't actually observe whether or not we have an id, ego, or super ego. All right. This is an unfalsifiable hypothesis. Okay. Now, let's talk about some approaches to research. We're going to talk about clinical and case studies, naturalistic observations, surveys, archival research, as well as longitudinal and cross-sectional research. When it comes to clinical or case studies, this is whenever we focus usually on just one individual. And so the difficulty with case studies is that we cannot generalize this information among a population. So we can learn a lot about this particular individual, but we can't say, okay, what happens and did happen to this person would happen to the remainder of this exact population. So there was a case study done back in the day with psychologists who there's a little girl named Jeannie, and unfortunately, she was held captive from birth and she was isolated. And so she never really developed proper language. She was never exposed to language. And then ultimately, what happened is whenever they did find her, she was rescued. She was never able to adequately learn a language. She would try to make certain noises to signal and make signals, but ultimately, language acquisition was significantly difficult. And so that did help, at least on that end when it comes to language. But what psychologists were more interested in was the effect of the social isolation on her development. Now, again, we can learn a lot about Jeannie's case, but it would be really hard to generalize that information among the larger population. Say what happened to Jeannie can happen to the rest of individuals. All right. But it does at least allow us a lot of information about Jeannie in particular. Now, naturalistic observations. These are experiments that can really get the most genuine and accurate behaviors out of the participants. Really hard um, to set up, but if you're successful in doing so, you'll get the most genuine behavior possible. Now, one of the things that's a bias within naturalistic observation is that whenever an individual, a part of the study, knows that they're being watched, they may try to skew their behavior to align with the observer's expectations. And if they don't know the observer's expectations, they will make ideas of what the observer wants. So that's going to skew their behavior, automatically making an observer biased. That's why within naturalistic observation, making sure that observer bias is eliminated will help make this as genuine and unbiased of a study as possible. Okay. Moving forward, we've got surveys. Surveys are really convenient because they can be delivered in a multitude of ways. This includes paper and pencil. So you're old fashioned, you meet up in a classroom or a room of your choosing. You give them a paper, they fill it out with a pencil or pen, and then you collect the data. Now, electronically, thankfully, with technological advancements, we can deliver surveys a lot more conveniently to individuals no matter where they're at in the world. You don't have to reconvene, and the good thing about electronic surveys is that it really increases the individual's anonymity. So it's completely anonymous, as well as verbally. A lot of qualitative studies, when I say qualitative, I mean has a lot to do with anything but numbers. It's strictly interviews and things like that. Quantitative research includes numbers, calculations, things like that. But when it comes to verbal, it's another easy way that people can provide you the information that you're looking for or particular answers that you're looking for. Okay. So moving forward, surveys really convenient. Archival research. So archival research, it can be convenient too, in the sense that you're utilizing other people's research to try to come to conclusions on your own hypothesis. So where this can be convenient, the difficulty that lies in archival research is that you don't have any control and you didn't have any control over how the study was conducted. So it may seem a little bit rigid or inorganic in places because you're using and you're bringing in other people's research to support your claims. So can be convenient, but it can also be a hassle or tedious at times when you're dealing with research that you didn't conduct yourself. All right. So longitudinal and cross-sectional research. This is important to pay attention to if you're in my class. And this is just important to know as well, the difference between cross-sectional versus longitudinal. So let's say that we are conducting a study that is looking into the effects of smoking since you were 18. So we would collect for cross-sectional research. It takes a lot less time to do cross-sectional research. And the reason being is because we've got our participants who are, let's say that we collect a group of 15 people, been since 18 at 25, we've got a group of 30-year-olds and a group of 35-year-olds. So obviously we'd be able to take care of that in an afternoon, right? Or maybe over the course of a couple days. So cross-sectional, it is comparing multiple segments of a population at a single time. So the different age groups, we're seeing how the effects of smoking have impacted these people at 25, 30, and 35. Okay. Now, when it comes to longitudinal research, gives us more accurate data because it's looking at the same people. However, it takes a long time, hence why it's called longitudinal. So this in the same study setup, we're studying the effects of smoking since the age of 18. So we check these people at 25, we check them at 30, and then 35. So this would be like a 10-year study ultimately to get that accurate data. And so, although it would be nice to somehow pull that off, the difficulty with these longitudinal research designs is because of attrition or the dropout rate of these longer studies. That's why whenever if you were to do something like this, you need to recruit more than just 15 people for longitudinal. And in general, to draw conclusions, you need at least 30 to show statistical significance. But we would have to gather hundreds, if not thousands, because uh, of the tremendous amount of dropout rates. And if the incentive isn't enough for them, or that they seem that it's worth it, they may just completely drop out in general. So attrition is a very big difficulty whenever it comes to longitudinal research. All right. So when it comes to analyzing that other part in the scientific method, we analyze our test that we did. We have to distinguish between a correlational research, correlation versus causation, as well as experimental research. So one of the most important things that you'll learn in this class is that correlation does not equal causation. What correlation does tell us is that there's a relationship between two or more variables. So that when one variable does something, the other does something. It can be in the same direction, it can be in opposite direction, but we just know that whenever um, one variable moves, the other does. So whenever there's a positive correlation, something that you're probably going to be tested on, a positive correlation are when the variables move in the same direction. So when one goes up, the other goes up, but also if one goes down, the other goes down. So that means they're going in the same direction and they're ascending from left to right. Now, when it comes to a negative correlation, it means that the variables are moving in different directions. So when one variable goes up, the other will go down, or vice versa. When one variable goes down, the other goes up. So it will make a descending line from left moving forward. Again, as I just mentioned, that big piece of correlation is just because there's a correlation does not indicate that there's some sort of causation. It doesn't mean that the variable is causal of the other. There may be something known as a confounding variable or a third party variable, something outside of the relationship that's causing both to move. So if you look to the graph to the bottom, you'll see ice cream sales versus drowning deaths. Now, we see a positive correlation with this, but does that mean that ice cream sales or ice cream in general cause drowning deaths? No. You'll notice at the bottom right there, whenever it's December, it's a lot colder out. And then we move toward June, July, and August, and the rates are very high. What's the third party variable or the confounding variable here? It's the summer months. Okay. It's getting closer to the summer months. So we're seeing an ascending line from left to right. Okay. But again, it just goes to show you just because two variables have a relationship does not mean that they're inherently causal of one another. It's just that whenever it's hot outside, more people are at the pool or in the ocean, as well as buying ice cream. Moving forward, illusory correlations. So this one can get people riled up because people like to believe in astrology and things like that. And I'm not discounting it by any stretch of the imagination, but from a scientific perspective, there's no way that we can actually prove that astrology exists, as well as some other things, such as the full moons causing elderly individuals to behave oddly at home or whatever the case is. To give a definition to illusory correlations are seeing relationships between two things, but in reality, no such relationship exists. So we can think that a full moon affects elderly individuals into behaving oddly, but it's just a fake correlation, if you will, or seeing a relationship when it doesn't actually exist in general. So I probably made some people who adhere to astrology mad, but according to, your text, according to science, we would see that as an illusory correlation when you see that relationship between what you're studying or what you're looking into versus what's happening. Okay. All right, designing an experiment. Now, whenever it comes to your experimental group versus your control group, your experimental group is the group that's going to receive the manipulated variable, and the control group is simply who you're comparing that group to. So let's say that I've got a sleeping pill or whatever the case is. I'm going to give the control group a sugar pill. It doesn't actually have the altering or the substance in it that can alter what you're experiencing. So that I am simply comparing that group to the group that's going to receive the sleeping pill. So the experimental group will receive the sleeping pill, and then I'm going to look at their differences after an hour or whatever the case is. Is the experimental group more drowsy? Things like that. How are they cognitively? All that. All right. So experimental group, simply comparing it to the baseline group or the control group, and I'm giving the experimental group the manipulated variable, what I'm actually trying to test. Okay. Now moving forward, whenever you're designing any sort of experiment, we have to understand that there can be an experimenter bias as well as a participant bias. So that's why we need to have adequate things in place to prevent these biases from happening. So we have what's known as a single blind study as well as a double blind study. So whenever it comes to a single blind study, the researcher will know which group the participants are in, either the experimental or the control group, but the participants do not, because obviously, if they know if they're receiving the sleeping pill, then they're going to act a little bit more drowsy, or at least their expectations of what will happen will make them feel more drowsy. Now, when it comes to the double blind study, this is whenever neither the researchers or the participants know which group that they're in. So this is where research assistants can come in handy. So if you do go in to let's say a questionnaire session with the individuals, you're not asking them questions in a way, either your tonality or putting subtleties in the sentences or questions that you're asking them that can influence their um, answers to align with what it is that you're trying to prove. A double blind study is really good for eliminating bias on both ends. Neither the participant nor the experimenter know to get the most genuine conclusions. Because as we're going back, the placebo effect is a thing. So when it comes to the placebo effect, our expectations or beliefs of what the outcome can be will influence how we experience a given situation. If I give you a sugar pill, but I tell you that it is the strongest sleeping pill known to man, and you begin to feel drowsy after about 30 minutes or an hour, you'll fall victim to the placebo effect because you truly believe that what you would experience is a sense of drowsiness from this pill. So your expectations influence the outcome of your experience in this particular given situation. All right. Moving forward, independent versus dependent variable, another item you'd probably be tested on, but it's important to know in general. And I'm going to make this as simple as I possibly can. The independent variable, whenever you're navigating examples, the independent variable is the variable that you are manipulating. Okay. Or what are you testing? Dependent variable is what are you testing? All right. So that's the best way and easiest way I can describe it for you before we get into these examples. So dependent variables always obviously dependent on the IV. Let's go into some examples. A study finds that reading levels are affected by whether a person is born in the United States or in a foreign country. Okay, so for this example, let's try to identify what the IV is. So, what are we manipulating here? Okay, study finds that reading levels are affected by whether a person is born in the United States or in a foreign country. So our IV here is going to be whether or not a person is born in the United States. Now, our dependent variable, what is dependent on whether or not you're born in the United States, what you're actually testing is reading levels. So that's going to be your dependent variable. A study finds that SAT scores improve when students have a tutor. So when it comes to your IV, what's being manipulated? We're going to manipulate whether or not students have a tutor. So the tutor is the IV, and the dependent variable, what we're actually testing is SAT scores. All right. A researcher studies how different drug doses affect the progression of a disease. So, when it comes to the independent variable versus dependent variable here, the IV, what we're manipulating is the different drug doses, right? And so, what we're actually studying, the dependent variable, is the progression of a disease. It's dependent on the different drug doses that you are receiving. All right. So, hopefully, that would help out in a test. Selecting participants. So this is important right here. Participants are the subjects of psychological research. Now, we can't, whenever we're finding our population, we have to have it make sure that it's random. Every single person in that population has an equal chance of being selected for participation. But before I get into that, the sample is the adequate subset of individuals selected from the larger population. So we need a good size group of individuals to be able to adequately represent a larger population. All right. And so the population is, of course, the overall group that I mentioned and the individuals that adhere to the particular area that you're interested in. Okay. So let's say that I go to the University of Tennessee, Knoxville, and I'm trying to find the average height of students on that campus. Of course, I'm not going to go to the women's basketball team because that's going to skew and bias my data. I don't have what's known as a random sample, which again, every single person has an equal chance of being selected for participation. So what I would do is I'd go to the quad area and I would try and measure at least 100 women. And being that's a good size number, that would give me a deep sample, the subset of individuals that adequately represent the larger population. So I'd probably get a pretty accurate average height of women at the University of Tennessee, Knoxville. Okay. When it comes to random assignment, this is the method of experimental group assignment in which all participants have an equal chance of being assigned to either group. That's what I just explained there. So everybody has an equal chance, not just of a random sample, everybody has equal chance of being selected, but has an equal chance of being randomly assigned. So going back to that study about the sleeping pill and the sugar pill, whenever it comes to the treatment or control, whoever receives the manipulated variable versus who's in the control group, they have to again be randomly assigned because if they're randomly assigned, then you're not picking people who may have a propensity for giving you the bias that you're wanting to support your data. Okay. So again, random sample, everybody has an equal chance of being selected. Random assignment, they don't know which group they're going into, either the control group or the treatment group. Okay. Or the experimental group is how I should say it. Okay. Now, whenever your data has been collected, you need to determine statistical significance. I'm not going to go into this too much, but the reason this is important is because of statistical analysis. It determines how likely any difference between experimental groups is due to chance. So if the odds of that the differences whenever you run your study, if the odds that the differences occurred by chance are 5% or less, then the results are significant. That means you can say that your hypothesis has been supported. Okay. All right. Moving forward. As I've said, whenever we come to conclusions, we don't just want to keep those conclusions to ourselves. We need to report that to continue to improve science in general. So, usually your research is reported to scientific journals. And so it's usually aimed at an audience of professionals and scholars, and these articles are peer reviewed. So, it's important to have other people looking at your work who are legitimate so they can sign off and say, yep, this is adequate research, this is accurate, and this is repeatable. Okay. So, more on that later. Reliability and validity. Just because something is reliable, just because you get the same thing every time does not mean that it's valid. So, reliability is important when it comes to science that you get the same result, the consistency and reproducibility of a given result, but the information has to be valid. That information has to be accurate. So, again, something to keep in mind. Just because you think 1 + 1 = 3 does not mean that it's valid. All right. I know that's very elementary, but it's a way that I can put it into context that makes it make sense. Now, whenever you, especially, are at an institution, but in general, you're going to have to adhere to an IRB or an institutional review board. Whenever you submit a proposal for research, they are going to determine if the ethics of the experiment are adequate. Because back in the day, especially when it comes to psychology, we ran a lot of studies that were unethical. And although it did give us a lot of information, we have to protect our participants as much as possible. That's why you can't just perform any study that you want to at any point in time. It has to go through an IRB. And once they sign off on it, one of the things that you're going to have to produce for your participants is what's known as an informed consent. This is a form that they will fill out or check mark or sign where they know exactly what the study is about, the implications of the research, potential risks that are involved, and that they know that their participation is strictly voluntary, that they can leave at any point in time. They do not have to stay for the study. All right. And finally, and what's most important is that their information will always be kept confidential. Their name, their identity will not be attached to your answers and I'll leave it at that, to your answers. All right. Moving forward. Sometimes in science, though, deception is necessary. So you purposely mislead an individual. But again, it's not going to harm the individual. It has to be deception that doesn't produce any sort of psychological torment or anything like that, or physical torment to the individual. Deception is just misleading the individual so that you can get more genuine results. Because if they know exactly what the study entails, they're going to be biased and have a tendency to either give you the results or maybe sway away from the results that you are after. We're trying to keep this as unbiased as possible. Now, if you do use deception, you have to debrief these individuals as soon as the experiment is over and you've gotten your results. You need to let this person know exactly what the study was, so they don't eventually find out this research or find it somewhere. And then they're like, holy cow, wait, they totally lied to me, right? You need to let them know exactly what happened or what the full truth is. Okay. Now, finally, the last slide I'm going to go over is concerning ethics with animals. About 90% of psychological research involves animals, such as rodents or birds, because as a substitute, their basic procedures are pretty similar to those in humans. But that doesn't mean you can just do whatever you want to these animals. You still have to aim to minimize pain or distress in these individuals. But again, animals are useful to utilize whenever the research would be more unethical in human participants. But then again, if you do decide to use animals, you're going to have to go through a whole other review board as well, the Institutional Animal Care and Use Committee, the IACUC. So they make sure that whenever they review your proposal for research involving non-human animals, and they can sign off on it to say that this will be an adequate study to perform.